Hey everybody, it's Adam from Tested, and if you're a regular watcher here, you know that one of the earliest build videos we shot was of a project that I've been working on for about 4 years now. It's from one of my all-time favorite movies, Hellboy, and it is Hellboy's Mecha-Glove. With incredible reference material, I've been slowly assembling all the bits, bobs, parts, and pieces to make my own Mecha-Glove, all with working lights and electronics and everything. Well, I'm almost done. And you might remember the man standing next to me. This is Sean Charlesworth. He is the winner of the Inventern from last year. And one of the things he got to do from being the Inventern is to be my Inventern. Yes, that's what the whole contest was about. So I've tasked Sean with actually helping me with a key part of the Mecha-Glove. I have built everything here myself, except for there's a piece that goes right here in this blank spot. It is a very complex sort of concertina of moving parts and little gears and stuff like that. And I stared at it for months, nay, years, wondering how I was going to make it. And then Sean won the Inventern, and it turns out that one of his specialties is 3D printing. And I tasked him with helping me build this thing, which is officially called the Mill and Ball Motivator, named after the machinist from Spectral Motion that built it. And Sean, you've been working on the Mill and Ball Motivator for a few weeks now, a few months.
For a few months, yeah. It was quite the project, yeah. Because as we discussed, it not only has all of these moving parts, it had to actually function.
Right.
Which frankly made me a little nervous.
So do you want to talk me through the process of figuring it all out from start to finish? You did. You sent me a bunch of prints like this from MakerBot, right?
Yeah, these are done at home on my MakerBot. So I was able to do a lot of prototyping right in my apartment, which was nice. And we were in the, early on, I was a little concerned about the size of some of these pieces because they're so tiny. And I was like, I'm not even sure on a high-end machine if that will be able to pull them off. So we went back and forth a few times about because you're trying to ride the line between being accurate and being functional. And I know that
sometimes they don't meet.
Yeah, and we talked about maybe modifying a few pieces or combining a few pieces to make them stronger and so on and so forth. And in the end, we actually we're able to build it pretty much like it is, which I was happy.
Now, I happen to know that Mill and Ball, who built this, they basically gave him this task and a rough drawing and said, go ahead and make this. And he went and added all this extra functionality. But it is one guy spending like weeks just doing this. Did you discover some of his problem solving while you were figuring it out?
Yeah, there was definitely some places where I could see where, because he was machining it all out of metal.
Right.
I'm doing this digitally, which in theory is easier, but you're reverse engineering it. So there's definitely places where I could see where, because you supplied me with lots of excellent reference photos. Yeah. So I was able to really get in there to the detail and see oh, that bent there, or this was hitting there, or you can see where they have to file this out to make room because they got into it and were like, oh, this isn't working.
Oh, so you could actually kind of surmise the progress that he made as
Yeah. So based on stuff that I was seeing that could be problematic or that they modify themselves, I made further modifications on mine. So it's relatively accurate, but some of the pivots had to be changed and some of the arms had to be lengthened or shortened. But I think the biggest challenge for me was the fact that we are reverse engineering this from pictures. Now, you provided me with a known measurement and really good photos that weren't distorted. So I was able to go on the Photoshop and get lots of measurements off of those to get it pretty darn close. Yeah. The biggest problem I had is building the crankshaft. So this has the crankshaft that runs down the middle and runs everything.
Now we had talked about originally maybe even sintering this out of metal.
Yeah, and I was like, well, you know what? Let's try it on the plastic printer, and at least it'll be a good reference. And I did manage to get it running with the plastic one, so we'll have to see in the long run how you'd like to handle it.
How well it holds up. And I mean, the original, these are shaft pieces that are actually with the little brass cams drilled and then all soldered together.
Yeah,
I was willing to do that if I had to. I didn't want to.
I don't blame you.
So also, I will tell you that your MakerBot print looks so much better than any MakerBot print I've ever done. Do you have a secret, or is it trial and error? You're just really, really good with the machine.
I have a machine that I've spent a lot of time tuning. So I've got some aftermarket parts, and I've dialed in the profiles for certain materials, and I'll usually go the extra step of measuring the filament so that I know exactly the diameter of it, which will also make it print a little nicer.
I see.
So, and I might print a little slower than you typically would, which will get you a finer print as well.
So do you have to like leave it going overnight?
Yeah, yeah.
Okay.
So like like one half of the block would maybe take like 3 hours,
Right.
something like that. So I mean, not too bad. And it was good enough to get. I was able to obviously prototype the whole thing using this. Now it's not super dimensionally accurate, so.
Right.
I had to know in my heart that when I printed it on the good printer that everything would be okay, but I might have to file some stuff to get it to work on this. And ultimately, I couldn't get the crankshaft to work on the MakerBot.
Oh, really?
It just wouldn't. I tried it every way I did. So going into the final, first
you were going
test
on
print,
faith for the
final. And this was all eyeballed, where I was basically in the 3D program. I was looking down the length of the crankshaft and lining up the lobes and being like, okay, it's not going to hit here and it's not going to hit here. And I got through one whole iteration and realized that I just made the assumption foolishly that this was centered right between the blocks. And that's the first.
It's not.
It's not. The first, it hit every single pivot over here.
No.
So I had to shift everything over, and then the cams on this side are a little different than the cams on this side.
Now, at one point in the making of this, I was in New York, so I got to visit your shop.
Yes.
And you gave me this to come home with and just have as a sort of inspiration.
Yeah.
And I'll tell you, the first thing that happened when I got home was I put this up to here and I was like, oh my God, it's too small. It's just this weird, because I've been thinking about it, and maybe because it looms so large in my brain.
It's deceiving. It's a mind bend, because I have that problem a lot working digitally, because all the photos you gave me are blown up like full size, like a full page.
High-res,
so I'm looking at these and looking at it, and like the first time I printed, I was like, oh, this doesn't look right. And I'm like, I'm measuring and remeasuring, but it's right on.
But then when you sent this and I put it there, I was like, oh.
Well, and the other point that I knew that we were good is that I was speccing out hardware that I thought was the right size.
Right.
And so I would, a nice little trick is you go to the McMaster, who has all the supplies in the world for industrial stuff.
Mechanical drawings.
And they'll give you the CAD model, so I download it and bring it right in, and that's how I figured out all the hardware. And so when I knew the hardware was lining up, it's like, okay, this actually is how big this is. And you gave me an idea of how big the crankshaft was, like the diameter.
Yeah.
And
I had some bearing material. I'd found some little tiny bearings, and this crazy little thing.
I know, this is great.
Isn't that beautiful?
It's beautiful. And so printing out a lot of this stuff, I was convinced this isn't right, but it's right on.
All right, so I guess we've teased it enough. Do you want to put together a final, or we've got mostly of a put together final here?
I can show you this. Yes, this is the finished prototype. Now, we changed a few different things. The first print that I got had despite how good this printer is, because these are some of the nicest prints that I've ever got off of any printer. It's dimensionally accurate.
Yeah.
So if you make a 3mm hole for the shaft 3 millimeters, it goes right into the bearing perfectly.
Right.
But the top plates here kind of turned out ridgy. It's got a texture to it, which I was a little disappointed about.
Well, that can be sanded out.
Yes, but so what I ended up doing, I laser cut the top plates instead.
Oh, okay.
Which need a little cleanup as well. Yeah. They got a little melty, but they were far cheaper.
Yeah, I can imagine.
So, and then so the first. This particular plastic is kind of like a polypropylene, and it has a nice little flex to it.
And that doesn't look like it's going to break very easily.
Yeah.
I have yet to see this thing actually operating.
All right, so let's.
So hold on. Let's count it down.
All right.
Oh man, this is so pretty. I love how light it is too. Oh wow, yeah. Let's take a look at the underside. That's the adjustable motor mount.
Yeah. So the motor mount can slide back and forth to adjust the chain tension.
That's great.
And.
Wow. All right, let's flip this puppy on.
All right.
Oh, look at that. That is so pretty. Doesn't look like there's much flex at all in the shaft.
Yeah, not on this one. The other one will a little bit more, but you can see down here it's a little weird. But
right, but we're gonna cut that.
Well, what I did, I was terrified to fire this up under full power. So I made a little hand crank that went on the spine, so I could very slowly test it, and so that was meant to be cut off when you're all done. So.
Now, is it possible to run it faster?
No, this is just a 3 volts. I don't have a speed control on it, so.
Well, hold on a second.
Yeah. It might fly apart.
All right.
Actually, I need this lead right there. All right.
Okay, so.
Crush your fingers.
Here we go. Starting slow. Because in the movie, it spins quite quickly.
Yes, yes.
So we're at 2.5 volts now, slightly less than your batteries.
I had it up to 4 volts. It did okay. So.
3.3. I'm just going to monitor it. I don't care about the voltage. I'm just going to stop when I feel like it's not safe.
Okay.
Dude.
I think we're good.
No, I'm going to keep going.
All right. Push it.
Yeah.
We got extras.
And there's so these aren't bearings in here. These are just
No, it's just a little
right.
oil.
Oh, fell off.
Well, luckily that's just the pin came out.
Oh, okay.
So it didn't break. The pin just worked its way out.
Is that the only single-sided?
No, there's many. Most of them are single-sided actually.
Oh, really?
The tolerances on this prototype I did are a little looser, so the pins work their way out after a while.
Oh, I see.
I made them tighter on your finals.
I'm just going to go all the way to 12.
I see wisp of smoke coming off.
No, you don't. Do you?
No.
Okay. Don't scare me like that. 11.4? 11.6?
Hold together!
That's about how fast it moves in the movie. I mean, I'm using the correct motor, so here we go. That's it, 12 volts. It's beautiful.
I'm frankly, I'm quite surprised.
That is gorgeous, Sean.
It's got a good sound.
It really does.
Yeah.
Oh, man. That is just great. Ah, it's gorgeous. All right.
Awesome.
A job well done,
successful. Thank you. I can't tell you how much fun I had on this.
It took a little longer than you thought.
It did, but it was just long enough that I just started to get sick of it. So
Sean, can you talk to me about the finish? This is absolutely magnificent.
Yeah. So I printed this with the. I'm very lucky to have access to the NYU 3D printing lab since I work up there, and they just got a new one, which is a 3D Systems ProJet, which is a SLS printer. So it uses liquid resin that it basically draws the part on the surface with a laser that cures it. Exactly.
Okay.
Yeah.
And then it rises, sinks and keeps on doing
exactly. Yeah. So it has there's support material that holds it up off the print bed that you have to clean off afterwards. But it's kind of this particular one is their flex material, which is like a kind of like a polypropylene. And so it has a nice give to it, and it's a little grippy when you first print it out, but the resolution on it is just phenomenal.
It is really.
It's the nicest prints that I've ever got. It's actually dimensionally accurate. So if you make a 3mm hole, it's right on.
I'm really impressed.
And I actually think that's what allowed us to do the crankshaft because while originally I thought this give was going to be bad, I think it actually works for it because it lets it give a little bit rather than break.
So. We need an aluminized finish on this. Have you done any experimenting with that?
Well, you're more the finishing guy than I am. I have done some stuff, but not a lot. But this particular stuff will take paint just fine.
Okay.
And you can even use regular paint or like Krylon Fusion or whatever.
Okay.
But I started messing around a little bit, and I tried a little rub and buff, which I thought turned out pretty not bad.
Not bad at all.
So this is the ABS, like the top plate. So that
Yeah.
was Scotch brighting it to get a little texture,
Yeah.
and then 2 coats of rub and buff, and then So I thought that was an option, but
Yeah.
I would love to hear your thoughts on it.
No. So I think that what I would probably do is take the full set of parts, sand them just to get rid of any little artifacts, and also just to soften them a little bit. These
There's
little
some ridging
round
there.
caps that have ridgy, I'd probably toss them on my lathe and hit them with a fingernail sander. This is a funny one. I happen to know the original effects company, Spectral Motion, hand machined all these caps, but You and I discovered that cigar tubes work just as well in our
The great,
weight.
yes, the great cigar tube search, yes.
When I wrote to Mike, who on Spectral Motion, I was like, "Did you use cigar tubes for that?" And he went, "Oh, we totally should have."
Well, and that led me to my wife and I spending a Saturday in the village with a pair of calipers going to cigar shops. Which I was
Buying them on a
I
metric
was like,
that
no,
no one
no,
buys
I
them."
just need your crappiest cigar in a tube, and that got some interesting looks. So yeah.
So yeah, I think we'd hit this with some primer, then hit it perhaps with, I think hitting these top plates with rub and buff makes the most sense, but maybe doing the body with a little aluminum spray paint, since it's a lot of area to cover.
It is, yes.
And then doing the same with these. These remove so we can paint these separately.
Yeah, they're just friction fits.
And then pop them in. I think we could. I think we're going to get something that looks 100% accurate. All right, Sean, it wouldn't be complete unless I showed you some of the lights actually working here. Let's see, where are you? There you are. Ta-ta. There's a whole bunch of the lights. When this goes, I'll have a microcontroller that makes it glow and
gorgeous.
And do that. Hand machine, all of that, and your piece is going to go magnificently right there, made out of aluminum. Oh, I just had
A twitch.
Yeah, a little twitch. And also, I actually designed machine plates for this.
Excellent.
And I have in German, it says serial number, model number, and everything. And then I thought, who would have manufactured it? And I thought, well, the Germans, at this point in the war, the Hellboy happens at the end, they probably would have gone to just the one place that would be able to do it. And I chose the guys that made the Enigma machine. So that's actually the name of the Enigma machine manufacturer, and this is for you.
Oh, excellent! Thank you.
And your write-ups up on Tested about this build, right?
I will be doing write-ups on how this whole process came together. It was a long multi-step thing, but yeah, it'll probably be a multi-parter.
We have a lot of reference to show of the entire build, plus Sean's progress. He took tons of pictures and kept me posted throughout the whole thing, and it's all going up on Tested.
Well, thank you for including me on such an awesome project.
I can't thank you enough, Sean. This is the very first time I've used 3D printing in a prop that I've replicated, and it's a total success as far as I'm concerned.
I'm glad it worked.